Okay, so now we're going to talk particularly about kites. A kite is a quadrilateral. It does not have any parallel sides, so you might want to write out here, no parallel sides. This is not a parallelogram, and that's what people get confused with it. A quadrilateral, it has two sets of consecutive sides congruent. I'm just going to write the congruent symbol here. I'll put this here so we kind of can keep the writing separate. Now, the things that are special about the properties of kites that are special is that the diagonals are perpendicular. Remember, we talked about this in the previous video. I'm just going to draw the perpendicular symbol. And the diagonals, well, I shouldn't say the diagonals. I should say one diagonal bisects the other. I'll show you a picture of what I mean. I've got one down here, but I'll go ahead and draw another one here. I'll just use this mark here. Okay, so let's say this is a kite, and this is one of the diagonals. The other oh man, I missed that one. The other diagonal would go down like that. If you notice, this piece and this piece are not the same. This is much shorter than this piece, so this is not congruent to that. But what this diagonal did do is cut this other diagonal in half. So we have a set of sides here that are the same. We have a right triangle here. They're perpendicular, so they form all these right triangles. All four of these angles are right angles. I said right triangles, didn't I? They form right angles. So if you think about it, you've got this side and this side congruent. You've got an angle here congruent, because these are both right angles. And then you've got this side congruent to itself. It's the reflexive property would say that a side was congruent to itself, so I'll mark it with 2 marks. So if you think about these two triangles, they're congruent by side, angle, side. Here we go, side, angle, side. Or this would be leg, leg is another way to look at this. But these two triangles are congruent, and we end up finding out, well, so are these two. They're congruent to each other, and these two are congruent to each other. But this one's not congruent to this one. So when you draw those diagonals in, this one does get bisected, but this piece up here is not equal to this one down here. Don't think that. Okay, one of the diagonals serves as a line of symmetry for the kite. Now, a line of symmetry is a line that if you draw it through a figure, one part of the figure is a mirror image of the other part. For the most part, if you think about taking a vertical line and splitting it right down the middle of your body, through between your eyes, through your nose, down through your belly button, you would have symmetrical sides of your body for the most part. And figures are that way too. So our line of symmetry here, we could think of this as splitting that kite into two mirror images of itself. And that's just kind of how we think a lot in geometry. When you move on to algebra, that becomes even more important because it allows you to fill in some missing points. If you had a point here, you'd know there was another point the same distance on the other side. So that's something that follows you into your Algebra 2 course that you'll take. We tend to not think so much about these lines of symmetry in a lot of the work we do in our geometry class. It's just not emphasized in the curriculum or in the state standards. But these two things are. Okay, so the diagonal bisects the other diagonal, and opposite sides are congruent. All right, so now let's look at some problems here just to kind of get the hang of these things. When I look at these, I always draw in these real right angles here so that I don't forget that I've got all these right triangles running around. Well, measure of angle 1 is right where those diagonals bisect, so I know that's a right angle. I drew that in when I saw the figure just to remind myself, and sure enough, they asked me about it. Measure of angle 1 is a right angle, so it's 90 degrees. Now, what's measure of angle 2? Well, if you remember, we said above that these two triangles are congruent to each other, the one that is on this side and the one that's on this side, just of this upper part of this kite here. I'm just going to look at this as two triangles that are congruent and they're just joined together by a shared side. Well, they tell me this one's 27 degrees. So this one here has got to be 27 degrees because these triangles are congruent. Actually, this angle here got bisected. It's got two equal parts. So this is 27 degrees. So how am I going to find this missing angle 2? Well, let's come over here and just look at this triangle for a minute. There's 90 degrees because it's a right angle. There's 27 degrees. So to find this angle, all I got to do is say, well, all the angles in a triangle add up to 180. So I need to add 27 and 90 and subtract it from 180. Well, that would be 180 minus 117. And let's see, that would be 63 degrees, I believe. So this missing angle here is 63 degrees. If I'm looking at example 2 of the kites, they tell me that this is 25 here. I'm going to go ahead and draw in my right angles because I know they're here, and usually it helps me solve problems with kites. It's one of the very first things that you have to kind of get your mind trained to think about when you see a kite. Well, if Ki is 25, they're wanting to know what Ks is in Si. So basically, oh, there is something I'm missing here. Se is 7. They did tell me that. Almost missed that. Se is 7. Okay, now if you remember, this is a diagonal, but this diagonal bisected it. It cut it in half. So if this piece is 7, then this piece is 7. That's my Si here. I'm going to come over here and I'm going to draw my triangle separately just so I can show you that we have, let's see, here's my K, here's my S, and here's my I. I'm going to just redraw this triangle so we can really concentrate on it and not have all the clutter of the rest of the figure. We said this side was 7 because this was 7. So if you look at it, I've got a missing side here. I'm going to use the Pythagorean theorem. Remember, the Pythagorean theorem says a squared plus b squared is c squared. And the thing I've got to be careful about that is this is my hypotenuse here. Well, in this figure, my hypotenuse is 25. So the 25 squared is going to go here. The SK, or KS, that I'm missing, I'm going to call that X here, just so I put a variable with it. So it's the 2 legs squared. So it's X squared plus 7 squared is 25 squared. Okay. 25 squared is 625. I'm going to move this 7 squared to the other side by subtracting it. So that's 625 minus 49. I'll put the calculator here so you can see what I'm doing. So 625 minus 49 gives you 603. Oops, I just typed that. Never mind, that's not right. Let's do that again. 625, the time I typed it in the right order, minus 49 gives us 576. And I believe this is a perfect square if we square root both sides to solve, because we want to know just what x is. So if I square root one side, I got to square root the other. Okay, so I'm going to hit second square root. That gets the symbol there. I can either retype the 576 there. That's one way I could do it. Now another thing is if I have the answer here and I want to put it in that box, I can hit the second key again and look down here under where this negative sign is right above it. It says A and S. If I hit that, it's going to put the 576 under the bracket. Whatever was my previous thing, it puts under that square root bracket. Okay, so I end up with 24. X is 24. Well, that was just my missing side, KS, so now I know that KS is 24. One more kite example. I keep drawing this figure. If you notice all through the notes, you're going to see me pasting it everywhere. And this is I really want you to get this in your head. Kites are not parallelograms. Here's parallelograms. These are not parallelograms. These are all quadrilaterals. They have the thing in common, quadrilateral. They're all four-sided figures. But remember, kites, they're not trapezoids and they're not parallelograms. So I'm just trying to keep this in front of you so that you see it all the time. Okay, MNO is 72. MNO. That means this big angle here is 72. Do you remember that this diagonal is going to bisect these two? This diagonal bisects this 72. So if I want to fill it in, 72 divided by 2 would be 36 degrees in each one of those little angles. And I bet they're going to ask me about one of them. Look here, MNP. Well, MNP was one of those little 36 degree angles. It was that 72 cut into 2, and it gave me 36. That diagonal bisects the angles. It actually bisects the long, we'll put it this way, the long diagonal bisects the 2 angles it hits. That's one way of wording it. It's kind of hard to talk about this sometimes. All right, MLN, though, another story. I don't know what it is. I do know that I got right angles right here. So let's see. They want to know what LOM is, like LOM. So they want to know this little angle, and they want to know MLN. Oh, that's this little angle. Okay, so they're wanting me to really solve for the angles in this figure. Well, I have to kind of go about it in a roundabout way. You look for the piece of information they gave you. They tell us MNO was 72, thus we were able to find 36 and 36. They tell us that OLM was 98, so these two added together are 98. Or this big angle is 98 right here. But if you remember, this diagonal comes in here and it splits it into 2 equal pieces. So this part ends up being 49 and this part ends up being 49 because 98 divided by 2 gives me 49. So I know what MLN is. It is 49 degrees. And that's because this was just this one bisected. So now, if that's 49 and that's 49, the only one I have left to figure out is this one. So let's draw this little triangle separately. We've got a lot of information here now. It may not look exactly the same, but we know this is 49. We know this is 90, and LOM, trace it. And remember, the middle letter is the vertex. It's talking about an angle here, but it goes from here to here. They only want this one little piece here. They don't want the whole angle. All right, so all I have to do now is remember that in a triangle, all of them add up to 180 degrees. So I need to subtract out 49 plus 90. Could write it this way. So that's 180 minus 139. And that would give us 41 degrees for LO. Remember, LOM just keeps going. I could have called it LOP, but they're calling it LOM here. So that's 41 degrees. Okay, so now we're going to talk particularly about kites. A kite is a quadrilateral. It does not have any parallel sides, so you might want to write out here, no parallel sides. This is not a parallelogram, and that's what people get confused with it. A quadrilateral, it has 2 sets of consecutive sides congruent. I'm just going to write the congruent symbol here. I'll put this here so we kind of can keep the writing separate. Now, the things that are special about the properties of kites that are special is that the diagonals are perpendicular. Remember, we talked about this in the previous video. I'm just going to draw the perpendicular symbol. And the diagonals, well, I shouldn't say the diagonals. I should say one diagonal bisects the other. I'll show you a picture of what I mean. I've got one down here, but I'll go ahead and draw another one here. I'll just use this mark here.